Hi folks, we're going to take a look at page 165, number 15. So we'll start by looking at the question in the textbook. So here we've got this function given with the graph given on the right, and they ask us to find the slope of the tangent at the point where the graph crosses the x-axis. So here I notice that there are two x-intercepts on this graph, but there's only one where it actually crosses the x-axis. Okay. Now, by the way, it also might as well point out that it doesn't really make sense to talk about the slope of the tangent at 0 anyways, since it's not differentiable there. There is no tangent at 0 because of the cusp. Okay, so our first order of business is to determine that other x-intercept, and then from there we can find the derivative to get the slope of the tangent. Okay, in part B, they want us to find the value of a, so that would be the x value, where you have this tangent here. But what's important about this tangent here is that it's horizontal. In other words, the derivative must be equal to 0. Okay, so let's go ahead and do the work. Okay, so the first thing we want to do is determine when this function is equal to 0. Okay, and I'll be honest, this question here I probably wouldn't give it on a test just because the algebra does take a certain amount of time. However, it's a really good question in terms of using our knowledge of exponents here. Okay, so I'm going to set y equal to 0. Okay, and here what I'm going to do in order to solve this, as we often do when we've got a couple of terms with x, is I'm going to factor it. Okay, so I'm going to factor it here by the smallest power of x, which would be 2/3. Okay, so I'm going to remove a factor of x to the 2/3, and some nice stuff is going to happen here because I've got my coefficient 2. But when I divide x to the 5/3 by x to the 2/3, okay, 5/3 minus 2/3 is just 3/3, or 1. So I'm just left with x. And then here in this second term, since I factored out the x to the 2/3, I'm just left with 5. Okay, so when I solve this equation, I get that either x is equal to 0 or 2x minus 5 is equal to 0. In other words, x is equal to 5/2. Okay, now we've already eliminated this one just by looking at the graph. We know it doesn't cross the axis there, and in fact not differentiable there. So we're focusing in on this x value here. So we want to find the slope of the tangent at that x value. Okay, in order to do that, we need to find the derivative. So that'll be our next step. So all this is part of a. So let's find the derivative of this function. Okay, so here 2 is just a constant, so I don't need to deal with it. I'm just going to multiply that by the derivative of x to the 5/3. So that's 5/3 times x to the 5/3 minus 1 is just equal to 2/3. Okay, so 5/3 minus 2/3. Minus 3/3. And then here we've got minus 5, again just a constant, and now the derivative of x to the 2/3 is 2/3 times x, and 2/3 minus 1 is negative 1/3. Okay, now if I was just asking for the derivative, I might ask you to just leave it like this. However, we actually have to do some work. We have to evaluate it at 5/2. So I think it would be best to simplify this a little. Okay, so I notice here I've got 10/3, and this also gives me 10/3. So the easiest thing to do is to just factor that out. And now let's work with what's left with our powers of x. So here I have x to the 2/3, okay, minus, and x to the negative 1/3 can be written as 1/x to the 1/3. Okay, and this is going to allow me now, by subtracting, to bring everything under one fraction. So let's do that. 10/3, and here our common denominator will be x to the 1/3. So x to the 1/3 times x to the 2/3. Again, that's just equal to x, because 2/3 plus 1/3 is 1, and minus 1 all over x to the 1/3. Okay, and I think we'll stop there in terms of simplification. So now we can go ahead and determine the derivative at 5/2. Okay, so 10/3, and here 5/2 minus 1, which is just 2/2. Okay, and then here 5/2 to the 1/3. Okay, and let's simplify a little here. So 5 halves minus 2 halves is 3 halves. So let me bring all the constants out together. So 10 over 3 times 3 over 2. That's from the numerator here. So now I'm left with 1 over 5 halves to the 1/3. Okay, and then here, nice simplifying going on. So 5 times, okay, and here 1 over 5 halves to the 1/3 is the same as 2/5 to the 1/3, okay, or 5 times the cube root of 2/5. Okay, now I believe the textbook has this simplified a little further, but if you want to check that this is indeed the correct answer, just stick it in your calculator, stick the book's answer in your calculator, and you'll see that it comes out to the same value. Okay, so just to recap, first thing we have to do is determine where the function crossed the x-axis, then find the derivative, and then from there we can evaluate the derivative at that specific x value. Okay, now if we take a look at B, okay, B came down to determining where the derivative was equal to 0. So I'm going to go back and take my derivative here, which, okay, I'll take this last version. So f prime of x is equal to 10/3 times x minus 1 to the over x to the 1/3. Okay, and we need this to be equal to 0. Okay, but this works out quite nicely because in order for, well, 10/3 can't ever be equal to 0, and the only way for this fraction to be equal to 0 is if the numerator is, so x minus 1 has to be equal to 0. In other words, whoops, x has to be equal to 1. Okay, and this was our value of a then, because that's the value where the derivative is equal to 0. Okay, so that's it for this problem here. So again, like I said, I probably wouldn't ask something like this on a test because it's quite time consuming, but definitely something that you are expected to be able to do. Okay, that's it.